In this episode, I'm going to look at a TPA3116D2 Class D digital amplifier that was sent to me by the people at IC Station to evaluate and test. So let's take a look at this little unit. Well, welcome to another video. I guess we better turn that off. I've just got a couple little speakers I picked up at the local second-hand shop that I was just testing out here to see how they sound. They actually don't sound bad. Anyway, on today's video, I'm going to have my little hybrid amp here that I built hooked up, but I have another little module that I got from IC Station to test out. This is another little Class D amplifier, so I figured we'll connect it up to these speakers and see how this one sounds. So this is the little board here. We've got our standard pins on the back here. We've got our power, ground and power, and our left out and our right out. Now this is obviously a bridge tied load, or BTL. So I'm going to connect it to these speakers. We're going to give it some power from the power supply, and we're going to check this one out and see how it sounds. Looks like the caps on here are, you know, like Chong-X. So nothing fancy on these. And it's a single chip solution. Now the power switch, it's got a power switch with a volume knob. So it should produce respectable sound. I don't think it's going to sound as good as the little hybrid amp, but it should give us respectable sound. So let's hook this one up and see how this little tiny amplifier that fits in your hand performs. So let's connect the speakers. One of the reasons I picked up these little basic speakers is for just testing these modules and amplifiers and stuff, so that I have a second pair of speakers that I can just keep on the workbench here, and if I blow them up, oh well, no big loss. Although these wires sticking out here bare like this, the chances of blowing this up are pretty good. The module, that is. We'll just try and keep the wires as short as possible into the terminal blocks here. Oh, there goes a thumbs down for a dog barking. Okay, input voltage on this little unit is 5 to 24 volts. So we're going to run it closer to that limit. It's based on a TPA3116D2, which would be a Texas Instruments chip, I believe. Sampling frequency on this is 1.2 megahertz, so it should actually have really good sound for a Class D amplifier. Two types of inputs. You've got your standard mini plug, 3.5 stereo, and it also has direct connection, so you can plug it straight into like a computer sound card, and one of these could be incorporated into a PC. I just have to extend my power leads here a bit because, of course, I don't think I'm going to be able to connect these directly. Okay, power supply is set for 24 volts. We'll turn on the power. And I've already got music playing from my phone here, so. That doesn't sound bad. Let's get some royalty-free music so that we can actually play the music. Okay, let's try this one. Sounding good. Let's just try something with a little bit more punch to it than that, but for the acoustic there, that sounded great. the current as I crank it up to full power. Doesn't even draw an amp. I can say it does not have the smoothness of the hybrid amp that I built. That's a given. It's a Class D amplifier, but it has a lot of power, produces virtually no heat, draws virtually no power. It doesn't sound bad for a Class D amplifier. You have to put everything in perspective, right? These Class D amplifiers are actually getting very good, and they are producing some really good sounds, but they are not to the level of a good hybrid or a tube amp. There's just something about that tube that really improves the sound. I bet you if I were to plug my tube buffer into this thing, it would actually warm this thing up as well. Watch the series Driving Television that was carried on Global in Canada, not this current season, but up to this year, you would recognize this music as this was the closing theme music that they used.
Take to the street.
I think what I'll do is I'll go grab the other amplifier again. We'll listen to the same track on the hybrid amp and just see the difference in the sound. That acoustic guitar doesn't sound quite as sharp as I remember it. Like, it doesn't pop. But we'll put the other one on. I don't know how the camera's picking this up, but to my ears, the acoustic guitar there doesn't sound quite as full as I remember it. Let me go grab the other amp and we'll do a direct comparison. So I've reconnected the tube amp again, or I shouldn't say tube amp, the hybrid amp, the Class AB IC amplifier with the two preamp tubes. Let's listen to that same track. Remember, I remember the acoustic guitar having more pop with this amp. Let's just take a listen and see if my ears were deceiving me. That's a quick little check of this thing. Maybe we'll hook the scope up to this thing and just see what the waveform looks like on the scope, or we'll hook it up again and we'll run the voltage down to 5 volts and see what it does there. But definitely sound quality wise, the hybrid amp is the clear winner. I mean, just even with everything else being equal, same song, same small full range speakers. They look like they've been through a war. Hey, they got them for $10, so I'm not complaining. For my test speakers for the bench, $10. If I blow them up, oh well, too bad, so sad. They actually don't sound bad for what they are. But yeah, just even on the same speakers, this one's clearly the winner. But again, if you've got a project that you know, you need a little small amplifier for, this is nothing to sneeze at, because it's, you know, it's inexpensive and it's all ready to go. So nothing wrong with this amplifier, but it's going to sound like a Class D amp. One thing I will mention about tubes is that these will pick up hum. If I hang onto the tubes, you can actually, they're actually amplifying noise that I'm picking up in through my body. And if you bang tubes, you'll probably hear the microphonics from the internals of tubes, which is always a downside to tubes. Take a listen. You might hear a little tinging sound there. Tubes have a tendency to be microphonic. Okay, I'm going to reconnect this little amplifier again. We'll put the scope on it and we'll look at the waveform. I don't want this video to drag on too long because it's just a show off this thing, but let's take a look at how this thing looks on the scope. So once again, same song. The acoustic guitar just doesn't sound as bright. I mean, it still sounds good, it just doesn't sound as good. Okay, let me get the scope going here. Actually, let's try running the power down on this thing. They say you can run it down as low as 5 volts, so let's turn it down to 5 volts and see what happens. We'll set the volume here. I want to see if the volume changes. It's doing exactly the same thing. Will it go as loud? That's the question. Goes into distortion very easy at 5 volts. So that's the first thing you notice, at a given volume, with the voltage is lower, it's going to distort, because obviously you don't have the same rail-to-rail power. You don't have, you've got 5 volts rail-to-rail maximum if you've got a 5 volt supply, and if you've got a 24 volt supply, you've got 24 volts rail-to-rail. So that's the first thing you notice, is that the distortion is much higher on low voltages. This should shut down if I go over 24 volts. So let's see what happens. Yep, it goes into shutdown. See where it shuts down, what voltage it shuts down at. Let's say 29 volts, it shuts off. So you can run it up to 28 volts, but if you go beyond that, it's going to shut down. And probably that's because the capacitors aren't rated anything higher than that. They're rated at 35, but the chip itself is protected. So if you over voltage this thing, it's going to shut down, which is a good thing. And if you overload them, it's going to shut down too. It's not going to blow up. At least that's what they say. They say the chip is protected against overloads, speaker overload, and over voltage and over current. It's all protected. So you're not going to damage this thing if you crank the power up like I just did to 32 volts, almost 31 volts. It's not going to hurt it. Okay, let's fire the scope up. Yeah, I have the scope. I should probably use the digital scope for this because it'll show up better on camera, but I have the scope on my reference to ground, and if I tap onto here, where is it? You should see the switching. There's our switching frequency. And if I play something through here, you'll see that will modulate. Because that's how these amplifiers work. There's the square wave. I was on the filtered side. I was on if you look down here, I was on the filtered side of the capacitor or the choke. Here's the square wave. Where are we here? There's the square wave. Where is it? There it is. So if I increase the volume, you'll see the duty cycle changing here. See the duty cycle changing? That's how these amplifiers work. As you've got a 50-50 duty cycle at 1.2 megahertz, and as the audio signal modulates it, as it increases in amplitude, the duty cycle will change. So as I increase the volume, now if I drop the voltage down, we will see this voltage drop accordingly, because of course this is a rail-to-rail voltage. So if I go down to the 5 volts, which is the minimum, okay, now we've only got what are we on here? We're on 5 volts per division, and I'm on a ×1 probe. So there's our 5 volts. You can see the scope's on 5 volts per division. Here's our 5 volts, our switching. The same thing happens, but because we have less voltage swing, we're going to have less volume, and our distortion is going to go up accordingly. If I look at the other side of the filter here, where are we here? Yeah, we'll just look at the switching side here for now anyway. What happens if I crank the voltage up? We're going to keep it going up and see what happens when I break that 28 volt. 22, 23, 24, what's going to happen? It should just shut right off. There, and it does. Chip goes into protection, shuts off the output. That is exactly what it's supposed to do. If we look at the filtered output, here's our audio signal. I can turn my waveform or my sweep down here, and this should be the audio, recovered audio signal. Now you will see some RF components that are still there, because there are going to be some RF components in the 1.2 megahertz range that are going to get through the filter. I mean, no low pass filter is perfect, but the signal that gets through the low pass filter is not going to get to your speakers. It's not going to do anything in your speakers. It's not even probably going to make it as far as the speakers itself, because it's going to dissipate very quickly in the speaker lead. But this is coming right out of the low pass filter, and there's the audio signal. And as you can see, the level is we're on 100, what are we on here, 100 millivolts per division? Yeah, we're on 100 millivolts per division, so we've got here about 250 millivolts of carrier leaking through, which is nothing, okay, compared to the audio signal. So here's the 1 volt per division scale. As you can see, about 250 millivolts of RF is leaking through. Now, of course, if I drop the voltage down here, I'll take it down to 5 volts. We'll watch what happens. It's just going to clip because, of course, it's going to try and exceed. It's going to try and produce a nice, strong signal, but our rail-to-rail is only 5 volts, so it's not going to go any higher than 5 volts. It's going to distort. See what I mean? But if I crank the voltage up, so, what have we learned here about Class D amplifiers? Give them more voltage, right? Yes, a lot of them will say they'll run at 12 volts, they'll run at 5 volts, they'll run at 6 volts. Yeah, they will. They'll run fine, but you won't get your power. If the amplifier is rated at 24 volts, use an old laptop power supply at 19 volts. That'll give you almost the maximum power that the chip is going to give you, and they'll actually sound not bad, you know, very respectable. I'm quite impressed with this current generation of Class D amplifiers, and I was never a Class D fan. In fact, I hated Class D amplifiers for years. I thought they were utter garbage, and the early ones certainly were utter garbage. But the current generation of Class D amplifier, I'm actually quite satisfied with the sound that they produce for what they are. Now, saying that, well, I'm a tube guy through and through, and I will listen to a tube amp any day of the week on twice on Sunday over a solid state amp. And that's me. Everybody that I know that's gone and bought a tube amp, one of my longtime clients, the fellow that actually has the Haflers and other equipment that I've serviced for him, he's actually picked himself up his first tube amp now, and I was just talking to him on the phone yesterday, and he was like, wow. He says, I can't tear myself away from it. He's got an old tube amp. He says, I can't tear myself away from it. And that is just the beauty of tubes. You don't need a full tube amp with tube outputs. I mean, yes, they sound great, and they're going to cost you a small fortune, but really all you need is a tube preamp. And there are many high-end solid-state amplifiers on the market these days which will use just 2 tubes. That's all you need. One for the left channel, one for the right channel, to give you that smooth sound that vacuum tubes deliver. And it'll be interesting. I should maybe make another video where I'll pull one of the tubes out of this and put it back in my other little tube buffer, because of course I pulled a tube out of that to make this one work. We'll plug the tube buffer into one of these Class D amps and see how they sound. But that's for another video, because this one's gone on far too long. We'll catch you again real soon. Thanks for watching.